Hello everyone, good evening. My name is Abdullah Shakir. I am from CUNY New York College. My major is computer science and I'm graduating this 2021 fall semester. Now, I am going to present my breast cancer prediction project with you. Breast cancer, one of the fatal diseases that can occur in both men and women. According to the World Health Organization report in 2020 alone, more than 2 million people were diagnosed with breast cancer. And sadly, another 700,000 people died because of this disease. Here in the United States, the National Breast Cancer Foundation has predicted only this year alone as many as 3,000 men and 300,000 women will be diagnosed with breast cancer. It is also estimated that 1 in 8 women in the United States will develop breast cancer in her lifetime. For breast cancer, early detection is the key. If the cancer is detected in early stages, then statistics have shown there are more than 97% chances to avoid any serious health issues, including death. Currently, if doctors find a tumor in a patient breast, they insert a thin needle into the area of the tumor to collect a small tissue. Then a pathologist checks that tissue to diagnose cancer. Some tumor can be benign, meaning non-cancerous, and some can be malignant, meaning cancerous. Depending on their experience, pathologists may take somewhere between 5 to 10 days to diagnose the tumor. As you all can feel, any mistake from the pathologist can cost patients their life. And this is where I believe my breast cancer prediction model can help. As you all know, machines work much faster than humans. They don't make mistakes if they get tired, and machine can find patterns from past data to predict with much higher accuracy. In this project, I am using breast cancer Wisconsin dataset from Kaggle to create a machine learning model. My dataset has 569 rows of data in 33 features. Here, all the values are computed from digitized image of needle-collected tissues of breast mass. Here I have all the features listed in my dataset, in total 33 columns. In my dataset, I have 357 rows of non-cancerous tumor data and 212 rows of cancerous tumors data. In this project, I used the supervised learning method to train my model to predict breast cancer. Here, among all 332 features, 32 features is used as input to predict values in the diagnosis column. For this project, I am using Jupyter Notebook, Pandas, NumPy, Scikit-learn, Seaborn, Matplotlib library from Python for data analysis, manipulation, and visualization. Here, I have a simple graph to show how some features can affect our cancer prediction. For example, when parameter mean value is higher, our diagnosis of cancer is low. Here, I have another graph which shows correlation coefficients among some features in my dataset. We can see in this graph, when concave point mean is increased, then diagnosis of cancer is also increased. Because concave points mean and diagnosis features have a strong positive relationship. To understand how correlation works, I also have a small table on the upper right side. In this project, I used random forest classifier to build and train my model. These are the confusion matrices for my breast cancer prediction model. A true positive is an outcome where my model correctly predicted the cancerous tumor. Similarly, a true negative is an outcome where my model correctly predicted the cancerous tumor. A false positive is an outcome where my model incorrectly predicted the cancerous tumor, and a false negative is an outcome where my model incorrectly predicted the non-cancerous tumor. My breast cancer prediction model has an accuracy score of 95%. It is the count of all the prediction the model got correct divided by the total number of prediction. My breast cancer prediction model has a precision score of 97%. It means when my model predicted a tumor is cancerous, it was correct 97% of time. My breast cancer prediction model has a recall score of 90%. This means out of 100 cancerous tumor, my model was able to correctly predict 90 cancerous tumor. My breast cancer prediction model has an F1 score of 93%. F1 score is the weighted average of the precision and recall. AUC, or area under the curve score, gives the best sight of understanding any classification model's performance. Here, my breast cancer prediction model has an accuracy AUC score of 98%. This cancer prediction model is my first machine learning project. I love doing each part of this project. I want to say thank you to my instructor Jack and my TA Julia. I appreciate all your help. And here are the references, and that's all. If anyone have any question, I'm happy to answer. Thank you so much.